if our measurements or results are precise, then they're in agreement with each other. And what do we use to determine our precision? When we write this, say our measurement is 4.67 grams, and we know that it can vary a little bit. How are we writing that? What comes after? Remember the sig fig inquiry?
Oh,
our
estimated digit?
Well, this is our estimated digit, the 7. What else do we tack on there?
Plus or minus?
Estimate, yeah.
Plus or minus.
1.1.
You're feeling this right now. That's the uncertainty.
0.0.
Right? You're uncertain of what you're supposed to be saying, right?
0.01.
0.01. Okay? So we go, whatever place our estimated digit is in, plus or minus. Now, it's not always .1. There could be more uncertainty depending on what a large group of results ended up to be. Remember, in the lab, we were off by like, 0.31 for our uncertainty of the density of aluminum in some classes. Hopefully, we're as close as just being 1 higher or lower. And what this means is that if this could be off by 0.01, it means, well, it could be 4.68 grams, or it could be 4.66 grams, somewhere within that range. So it gives us the maximum and minimum. That's what that uncertainty does. And it's like saying, okay, it's 4.67, give or take a little bit. And whatever that little bit is based on the measuring device we're using. Okay. Awesome. Number 7, write measured quantities with the correct number of sig figs. So this is going to be a question that says, which of the following measurements is expressed to 3 sig figs? And you're going to get answer choices that look something like this. I guess I better stick with black so you can see it. Oops. 5055. Let's make these all meters. 0.0005 meters. 5.05 times 10 to the 3rd meters and 0.05 meters. Okay? Which of those, if any, are expressed to 3 significant figures? Okay, we have 1 vote for this one.
I second that vote.
We have a nomination and a second. All in favor? Oh, not very many people in favor. Okay, who thinks it's this one? 3 sig figs. No one? Okay, how about this one? Well, how many sig figs does this first one have? 4. How about the second one? 1. These are placeholder zeros. Decimal point is present. We're going to start on the Pacific side. We go all the way over until we hit a digit. That's our first sig fig. Okay? How many does this have? 3. Decimal point is present. So we're going to start on this side, and we're going to hit our first digit. Sig fig, sig fig, sig fig. We ran out of number. Okay, this one has 3 sig figs. So good job, 2 or 3 people that were confident. How about this last one? 1. Again, we've got a decimal there. We're going to go way over here before we hit our first sig fig. Okay, so you'll see answer choices like that. So you're going to have some captured or trapped zeros. You're going to have some placeholder zeros. There might be one. Maybe there'll be an example written this way. This one would have 3 sig figs. But they'll be very similar to that. Question number 8 is just identify the number of sig figs in a measurement. I just talked you through that when we went through each of these examples. So you need to be able to recognize and count sig figs. Number 9, you are going to multiply or divide numbers in scientific notation and then write them with the correct number of sig figs. So, it will be something like this. 2.0 times 10 to the negative second meters. And we'll multiply that times 5.1 times 10 to the positive second. Okay? How would you write that final answer in correct sig figs?
Units.
Oh, meters, thank you, Mr. Sustin. Now what do we do?
Add them.
Apparently we freeze as if we're in headlights.
Add them.
Stranger danger.
Right.
I'll leave
We
it.
add what?
Exponents.
Okay, well what do we have to do to the 5.1 and the 2.0? Multiply. Now, when you punch that in your calculator, aka your head, what do you get when you multiply 5.1 times 2? 10.2. Okay, and what are we doing to the exponents? Subtracting. Really? We're multiplying here. Adding, so negative 2 plus 2 is 0. Well, this is weird. 10.2 times 10 to the 0? We're not done. What do we have to do?
Move it over a place.
Move the decimal back over so we have a number between 1 and 10. So this is really going to be 1.02 times 10 to the first meters. Now, are we sure on that? Or does that match our sig figs? I ask it with that nasally tone of voice because clearly it must not be. It does?
It is.
Oh. How many sig figs are in 2.0 times 10 to the negative second?
1,
2.
2,
How many are in 5.1 times 10 to the second? 2. Which is lower, 2 or 2?
2,
2. How many go in our answer?
3,
2. How many are here right now? 3. What do we have to do to this? Huh? Scratch this out because this would round down. So just 1.0 times 10 to the first. Right, now that was the kind of long way, but I want to talk through it so you understand what you're doing there. Alrighty, number 10. Oops. Oh. Identify the correct number of sig figs in a calculated answer when multiplying and dividing. This is the same as the process we went through here, only this is going to ask you in words. When you multiply and divide, how many sig figs go in your answer? The number of sig figs that matched the measurement that had the least, or the one that was least precise. Watch the difference between precision and accuracy on the Moodle quiz. Some of you are using that term, those terms interchangeably, and they're not the same thing. Some of you are saying accurate when you mean precise, or precise when you mean accurate. Little hint there. Alrighty. Number 11. You're going to calculate the volume of a cube, and you're going to be given the length, width, and height in scientific notation. And, very nicely, because your chemistry teachers love you, they're all going to be in the same measurement unit. In honors chem, we would give like some in meters, and some in centimeters, and some in millimeters, and they'd have to convert them to match. So what do you do with length, width, and height when you're calculating?